Hello, Year 13 doubles. So this is just a quick kind of like a fix for the horrendous mistake I made in the other video where basically Geogebra was invisible. So hopefully this time this will work. So just give me a moment. We were at this stage. I basically hand-drawn sin x like that. I won't write them on the values, but that's minus 360 or minus 2 pi. That's minus pi or minus 180. 0 naturally, 180 or pi, and 360 or 2 pi. Sine x is obviously the yellow curve, and I was just basically trying to show you how you can construct cosec x from kind of like just like logical deduction. Yeah, cosec x, which is 1 over sine x, well, when sine x takes a value of 1, which is naturally, let me do that in black actually. Cosec will take a value of 1 when x is pi over 2 or 90, yeah, depending on whether you're in radians or degrees, or it will take a value of of minus 1 at 270 or 3 pi over 2. And sorry, my graph's so wonky here. This is why I wanted to show you it on Geogebra, because, yeah, let me just show you it on Geogebra now. I kind of got that far, and I just want to show you it on Geogebra. Hopefully this is working now. Y equals sine x looks something like that. Y equals cosec x. I don't think they have cosec. Oh, they do. So you can just type in cosec directly. You can put in 1 over sine x or cosec x. Let me type x in there, and you get this. Now, this is a nice way of looking at it because it's not drawn by my poor, my poor penmanship, should we say, whatever you call it. Let's get it so we're just in the same range as well. So we've gone up and down once on the right hand side and left hand side. So yeah, like I say, basically the curves kiss at the maximums and minimums, but they have asymptotes where sine x is 0. And that's because you're doing 1 divided by 0. And 1 divided by 0 is undefined. So the cosec x curve is undefined where sine x equals 0. That's the only point I wanted to make. You can see for yourself then, and I strongly advise you to just, you can use Geogebra in the browser. So by all means, just look up Geogebra and look up these curves in the browser. It gives you a lovely picture of them. If we're doing y equals cos x, it's really, really similar to y equals sec x. It's just going to kiss at the maximums and minimums and have asymptotes where the curve is 0. Lovely. Tan x, that's a really difficult one. So yeah, if I was going to learn or memorize one of them, it would be I know what tan x looks like. I know it has asymptotes at pi over 2 minus pi over 2. I'm talking in radians, obviously. Well, you've got to basically move it 90 degrees to the left and then reflect in the y. So imagine that moving pi over 2 radians or 90 degrees like this direction, and then being reflected in the y-axis. That should give you y equals cot x. I guess they've got cot, yeah. And you get that. So it's been moved like that and then reflected in the y-axis. In fact, let's take tan x off. Oh, don't know what I'm doing here. Hang on. Yeah, let's take tan x off so we can just see cot x there. So it looks really similar to tan, but like not tan, because that is not tan, is it? See what I mean? It's really, really similar. That one's a hard one to get your head around. It's another way of looking at it is it's been reflected in the x-axis, if you like, and then moved 90 degrees to the right. That's an equally good way of looking at it. Look at it as a reflection and a movement and a translation of 90 degrees. That would be my advice to you. Okay, I hope that video is useful and helped you better understand what I was talking about when I was waffling on about a blank white space. And yeah, best of luck with course. Contact me at school at the relevant times if you're stuck on any questions. Good luck.